Good day. For those of you who do not know us, we're the instructional staff for ECE 150, Professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to introduce this course and discuss the Hello World program. So, in this topic, we will describe what a program is. We will define a programming language. We will look at our first program, Hello World. We will introduce the concept of an integrated development environment and the use of online compilers. We will describe the steps of compilation of a program. To start, a program gives instructions to a processor to take data, be it numbers, text, or more generally any sort of information, and perform some sort of operation or processes on that data to solve a particular problem. That problem may be something like, given two integers, calculate the GCD, or it may be given information from two sensors, determine when and if to apply the brakes to a moving vehicle. Now, initially, our program will be giving instructions to the processor to simply take some data that appears in the program, and it will be hard-coded into the source code you will write, to take that data and create some output. And in this case, the output will simply be displayed to the computer monitor. Now, by the end of this week, we are also going to get data from a very simple input device, the keyboard. So now the program will issue instructions to the processor to interpret and use the data from the keyboard to produce appropriate output. Now, C++ uses a little bit of an antiquated language, and so we need a definition. The console is referred to as the combination of the keyboard and the screen. So we are going to discuss about console input from the keyboard and console output to the screen. Now, by the middle of the course, we will also be accessing data from and storing data to files stored within a file system. That file system will normally be on a hard disk drive or on a solid state drive. However, it could also be, say, for example, on the cloud or some sort of other drive or storage system. In upper years, you're going to investigate a different type of system, an embedded system, which tend to actually be much simpler. Here, your program will issue instructions to the processor to read data from sensors, that is, reading information about the external environment, and then responding appropriately to that information by sending data to actuators, and these will activate mechanical and electromechanical devices in order to appropriately respond to the environment as described by those sensors. In general, a program gives instructions to the processor to receive input, be it from keyboards, mice, microphones, image scanners, cameras, or sensors, to communicate with other devices, perhaps through expansion buses, Ethernet, Bluetooth, a CAN bus, etc. To read and store data on external storage, so file systems or databases on hard drives, solid-state drives, floppy drives, optical drives, tape drives, or perhaps the cloud. And to produce output, be that to monitors, printers, speakers, or actuators. However, this is getting to be very confusing and complex. Here's a simplified model. A program provides instructions to the processor to communicate with devices in order to retrieve, process, store, and send data. Why learn programming? Well, programming is a systematic means of giving instructions to perform a task. That's it. And that's actually what an engineer is doing all the time. Anytime an engineer writes a report, they are systematically describing a system in the real world. Anytime an engineer designs something, that design contains instructions to create an appropriate device to perform a specific task in a manner that is safe to use and hopefully efficient. Now, a lot of you are electrical engineers, and you may be wondering, I got into electrical engineering because I don't like programming, so why do I have to learn this? Yes, well, the thing is, electrical engineers today do have to program. And to help you, we have authored one website to understand why the material in this course is relevant. You can view it here. Now, when you execute, open, run, launch your program or application, your computer, laptop, or smartphone simply begins executing instructions. These instructions are coded in the processor using binary encoding. That is, in the physical world, 0 volts or 5 volts, or as we will see in undergrad, zeros and ones. Now, all of this you will see later in your courses on digital circuits and digital computers. Now, the set of all possible instructions that you can send to a processor defines a machine language. Machine languages are not easy for humans to read. They're actually quite difficult. Now, there are actual sources where you can look up each of these values and determine what instruction is being sent to the processor. But for the most part, humans aren't very adept at dealing with code in this format. Now, a programming language is a human-readable means of specifying the operations the processor is meant to perform. Programming languages are used by a programmer to author source code. These source code instructions are then compiled and translated into machine instructions that the processor can then interpret. The resulting instructions can then be executed as a program. Now, note, there are some programming languages that are interpreted. That is, as soon as you type in an instruction in that programming language, the programming language will then, or interpreter, will then immediately execute that statement. This is very different from C++, and we will describe the process of compilation in a few slides. Now, programming languages are made up of characters that are generally those that appear on the standard keyboard. These are derived from ASCII, or the American Standard Code for Information Interchange. You may notice that a typewriter from the 1800s may have certain keys, such as 1/2, or a pound symbol, such as the British pound. However, ASCII restricted the number of characters that can be coded to a specific set, and consequently, today's keyboards generally contain every single character that can be coded using ASCII. Hence, this is the set of characters that will be used to design any programming language. Now, one interesting detail, all of programming falls under the domain of mathematics. And rightly so, the Sheridan School of Computer Science at the University of Waterloo falls within the Faculty of Mathematics. Now, you learnt mathematics through all of elementary and secondary school. However, we cannot use mathematical notation in programming languages, and thus there must be some other means of describing our intentions. Here are a few examples. On the left-hand side are the expressions that you would normally use in a course in mathematics. However, if you were to translate this into C++, you would have to use notation that is appropriate for the commands and operators that the C++ language allows. So here's our first program. Before we get into the details, let's think about this as follows. If you have a recipe, your recipe calls for certain ingredients. Well, in this case, we list the ingredients first. What is necessary to get this program to do what it has to do? Here we actually need to have a library which allows us to print to the console, and we need a function called main. Now we'll get into that later. Here we actually see the code that tells the processor what to do while this program is executing. Now, most important here is not the code, but the English comments that are added to help the programmer understand what's going on here. In future topics, we're going to look at function declarations and function definitions, but right now, the most important comment here is this one here, which essentially tells us what this program does. Display this text, well, it looks like the text there is hello world to the console, so print that to the screen. Comments are any amount of English text that appear after a double slash up until the end of that line. So this piece of code has 3 comments, and those comments help you understand what the code actually is intended to do. Now, there are different ways that you, the student, can approach this process of authoring, compiling, executing, and testing your code. We are going to use an integrated development environment, or an IDE. Now, what does this mean? Integrated means including together all the tools that are necessary to develop software. And it's going to run as an application, hence it is called an environment. We will go through the tools that an IDE has throughout this course. But most importantly right now, you will know that it has some place where you can edit your code, and you can then compile and observe the output. In this course, we are going to use Eclipse in the laboratories, but you are more than welcome to use whichever IDE you wish. There's also online compilers available, such as repl.it. If you go here, you can actually just open the web page, create a program, author it, and then execute it with a click of a single button. It will even save it for you. This is not a bad idea if you just want to learn to program quickly. However, this is not the environment you will be using while you are a co-op student in the real world. And some of you may use a text editor such as VI or Nano or some other way of editing code, say Notepad++. Together with this, once you've created your source code, you can then compile it with a command line compiler such as GCC or some other command line compiler that you have downloaded installed on your system. Now, online compilers are probably the easiest to use for a first-year student, but again, remember, in the real world, they may not always be available, and they become increasingly useless for larger and larger projects. So while you may use an online compiler for the first quarter or half of this course, try to wean yourself off of those online compilers and move to an integrated development environment. or if you want, a text editor and a command line compiler. But that's not going to be a cup of tea for most of you. Here we see our first program in repl.it. And as we can see here, we can author the source code, and then there's a button up there that says Run. As soon as we run the code, then we see the output on the console to the right, and we actually see that the output is, as you would expect, Hello World. Now, here we're focusing on the output, and once you've selected the Run button, text is printed to the console output. Now the question is, what happened here? What happened between you authoring the code and hitting that Run button? Well, we're going to go through the steps right now, and you don't need to understand these steps in detail at this point, but we're trying to explain to you what's actually happening. Once you get to your third-year course on compilers, you will go into much more significant detail as to the process of converting a source code program into an executable program. So the first step you take is you author the program using your programming language of choice. And you're going to be doing this in some sort of editor. And if you're using an IDE or integrated development environment, that IDE will include an editor with the whole ensemble. The next step is to take the instructions you have written and convert that into machine language code. That is the step of compilation. Now, a little bit beyond the scope of this course is a process called linking. You may see this appear in text as the compilation process is going. Linking is a process of finding other libraries that other people have authored and including it with your executable. For example, you did not author code to print your text to the screen. You are using someone else's code to do that for you. The linking process combines that code with the code that you have authored. Finally, the linker takes everything together and produces an executable program which you can then run. So, following this topic, you now understand what a program is. You have an overview of how compilers or how computers execute instructions, and these are going to be encoded in binary in hardware with zeros and ones, or in reality as 0 volts and 5 volts, or some other non-zero voltage for 1. You understand that programming languages allow us to define programs in a human-readable interface. Now, you may be looking at that first program and say, that's not readable. I have no clue what most of that is. That's okay. That's what this course is about. However, once you have that program, you must then compile it into an executable and execute that program. Now, we've written the first program in C++, the ubiquitous Hello World. We saw how it would execute on repl.it. The first lab is going to include you installing the Eclipse IDE. You are not required to use this, but of course this is the only IDE that we will be supporting. If you are using a different IDE, our TAs may be able to help you, but they may also not be able to help you. However, if you're already using your own compiler and your own IDE, chances are you know how to do an appropriate Google search to help you solve your problems. Finally, you understand the steps of compilation, the actual process of taking the source code that you have authored and converting that into a running and an executable program that can then be run. Here's the references. acknowledgements, the colophon, and a disclaimer. Cheers!